So we can consider every instruction to be consisting of a set of one or more of these operations which are executed in a proper sequence with the help of the control signals generated by the control unit. Also, the operations corresponding to the instruction are executed within time periods called clock cycle. So by producing proper control signals at proper clock cycle, the data movement corresponding to the operations of an instruction is done in a timely and controlled manner. So consider our example. First of all, instruction has to be fetched. For that, the address of the instruction which is available on the program counter has to be moved to memory address register. Mean the content of the program counter should be transferred to memory address register. This is a register to register data transfer or a data movement between the registers. For every register, there are two control signals which are used to control the data flow with respect to one particular bus. One in signal to take the content of the bus onto the register and an out signal to keep the content of the register onto the bus. So for program counter, there are two control signals, PC in and PC out. PC in to load the content of the bus onto the program counter and PC out to place the content of the program counter onto the bus. And for memory address register, the address moves only from the processor to the external bus. So for memory address register, one in signal is used to keep the content of the bus onto memory address register. So suppose we are now at clock cycle 1. Here, to transfer the content of the program counter to memory address register, we produce two control signals, PC out and MAR in. PC out signal will place the content of program counter onto internal processor bus, and MAR in signal will load that content from the internal processor bus to the memory address register. So at clock cycle 1, both the signals PC out and MAR in are made active. And the output of the output register, here the output of the program counter register, will be immediately available on the internal processor bus. But suppose all our registers are made of positive edge triggered flip-flop. Hence, the inputs of the registers will respond only to the rising edges of the clock cycle. So even though here the data is available on the bus, that data will be loaded into the input of the register only at the next rising edge. So the PC out signal will immediately place the data on the bus, but that data will be taken to the input of the memory address register at the next rising edge, and then immediately both the signals go down. So the content of the program counter is transferred to the memory address register. So this is how generally a register to register transfer occurs. So here we assume that every data transfer within the processor takes place within one clock cycle. Also, while the processor bus is occupied with some data with some out signal, at the same time we cannot keep some other data on the bus with some other out signal, should wait for further clock cycles or the next clock cycle. Now the address of the instruction is available in the memory address register, which has to be kept on the external address bus. So let's assume that as soon as the memory address register is loaded with the address, that address will be immediately available on the external address bus at the beginning of the next clock cycle itself. So we are not using any out signal from the memory address register to external bus. We assume that as soon as memory address register is loaded with the address, that address will be available on the external address bus at the beginning of the next clock cycle. So when memory address register is loaded, at the same time a read control signal will be issued by the control unit onto the external control bus. So keep the content of the program counter onto the internal processor bus, load that content into the memory address register. At the same time, issue a read control signal onto the external control bus. So at the beginning of the next clock cycle, when that address is available on the external address bus, at the same time, at the interface circuit, a memory read signal is generated in order to read the corresponding data from the memory onto the external data bus. And when the data is available on the data bus, in order to read it to the memory data register, we keep the MDR in E signal active. We know that whenever the data is available on the data bus, it should be loaded to the memory data register, and the memory data register is connected to the internal processor bus as well as the external bus. Hence, for memory data register, there are two control signals with respect to the internal processor bus, MDR in and MDR out, and two control signals with respect to the external data bus, MDR in E and MDR out E. So to load the data from the external data bus to the memory data register, we keep the MDR in E signal active. But we do not know when the data will be available in order to get loaded to the memory data register. Here we assumed that within the processor, every data transfer takes place within one clock cycle. But from an external memory or external device, it usually takes more than one clock cycle. So suppose one signal called MFC, memory function completed signal, indicates that the data is available on the external bus. So after keeping the MDR in E signal active, we wait for the MFC signal. Suppose it took 3 clock cycles for the data to be available on the external data bus. Hence, correspondingly, an MFC signal is generated at this point to show that the data is available. Thus, the data is available now and MDR in E signal is active, but since the input of the registers are connected to positive, will respond only to the positive clock cycles. It will wait for the next rising edge of the clock cycle, and at this point the data will be transferred to the memory data register, and immediately after that all the signals go down. So now the data corresponding to the address, which is our first instruction, is available in the memory data register now. And from the memory data register, it should be transferred to the instruction register to complete the fetch phase, means a register to register data transfer. For that, we use the two signals MDR out and IR in order to transfer the content of the memory data register onto instruction register. And at the next rising edge of the clock cycle, the content will be taken to the input of the instruction register. And immediately both the signals go down. So now the instruction fetch phase is over. Instruction is loaded to the instruction register. So here we have covered the control and timing for register to register transfer and also from memory location to register transfer. So in the fetch phase, as step 1, we transfer the content of the program counter to the memory address register. We assume that as soon as memory address register is loaded, that address will be immediately available on the external address bus at the next clock cycle. So along with loading the memory address register, a read control signal will be issued by the control unit to the external control bus. At the beginning of the next clock cycle, the address will be available on the address bus, and at the interface, a memory read signal will be automatically generated. Within the processor, we keep the MDR in E signal active to receive the data and also wait for the MFC signal. When the data becomes available, the MFC signal go high and the memory data register will get loaded with the data at the next rising edge. So in the next step, we transfer the content of the memory data register, which is the instruction, to the instruction register using two signal MDR out and IR in. So we have fetched the instruction to the instruction register within the processor. That instruction will be decoded by the instruction decoder and control unit to produce the control signals for the further operations. So now our instruction is fetched and decoded. Now it's ready to be executed. We need to fetch the operand first. One operand we have to fetch from the memory. We have already discussed the memory read in case of fetching the instruction. So for that, we need to load the memory address register with the address of the operand. At the same time, a read signal will be issued by the control unit to the external control bus. And we assume that as soon as the memory address register is loaded with the address, that address will be immediately available on the external address bus at the beginning of the next clock cycle itself. And when the address is available, at the interface a memory read signal is generated in order to read the corresponding data from the memory, and at the same time we keep the MDR in E signal active within the processor in order to read the corresponding data into the memory data register. But we do not know when the data becomes available, so we wait for the MFC signal, memory function completed signal. When the data becomes available, an MFC signal will be generated and the MDR in E signal is already active. At the next rising edge of the clock cycle, the data will be copied to the memory data register. And soon all the corresponding signals go down. So to fetch the operand from the memory, we load the address of the operand to the memory address register and generated the read control signal. When the address becomes available on the address bus, we kept the MDR in E signal active and waited for the MFC signal. Now the operand is available in the memory address register. So this is an add operation to be executed. One of the operand is available in the memory data register and the other operand is available in the general purpose register R0. So the operand from the memory data register can be fed to the ALU through the internal processor bus. And while waiting for this operand itself, we can transfer the content of the general purpose register R0 to the temporary register Y. Hence, the memory operand becomes the operand A and the operand from R0 becomes the operand B by selecting Y. Now issue the proper control signals for the ALU add operation. The result will be loaded to the Z register. So finally, we have the result in the temporary Z register, but this result has to be written back to the memory. So one memory write operation is also required. In order to write back the result to the memory, we need to load the memory address register with the address to which the result has to be written, and the content of the Z register will be loaded to the memory data register by using the two control signals Z out and MDR in. Now the data is in the memory data register, and as soon as the memory address register is loaded, that address will be immediately available on the external address bus at the beginning of the next clock cycle itself, and the data in the memory data register is fed to the external data bus using the signal MDR out E, and a write signal will be issued by the control unit to the external control bus. And we wait for the memory function to be completed. We will wait for the result to be written to the corresponding location. So to summarize, first of all, the address of the instruction will be available in the program counter. It will be transferred to the memory address register. At the same time, a read control signal will be issued by the control unit to the external control bus. So the address becomes available on the address bus, and hence we keep the MDR in E signal active in order to read the data corresponding to the address into the memory data register from the external data bus, and we wait for the memory function completed signal to identify when the data becomes available. Whenever the data becomes available, it will be loaded from the external data bus to the memory data register. From the memory data register, we will transfer the instruction to the instruction register in order to be decoded. And in this fetch phase itself, we can increment the program counter by using PC out. Now the content of the program counter is available on the internal processor bus. It can be directly fed to the ALU, and the other operand can be selected as 4. Now select the proper control signal for the add ALU add operation. The result will be loaded to the set register. From the set register, it can be transferred to the program counter. Hence, the program counter will be updated to point to the address of the next instruction to be executed. Here we are not considering the branch or jump instruction, to just understand the normal flow. Now the instruction is fetched to the instruction register. It will be decoded by the decoder and the control circuit. We have two operands, one operand from the memory, other operand in the general purpose register R0. To fetch the operand from the memory, the address of the operand will be loaded to the memory address register. At the same time, a read control signal will be issued by the control unit to the external control bus. Now the address becomes available on the external address bus, and hence we keep the MDR in E signal active in order to load the data to memory data register from the external data bus and wait for the memory function completed signal. When the data becomes available, the operand will be loaded to the memory data register. At the same time, while waiting for this operand, we can transfer the content of the general purpose register R0 to the ALU temporary register Y. And when the data becomes available in the memory data register, we will just transfer it to the bus and then to the ALU. Now by selecting Y, we produce the necessary control signal for the add operation. Result will be kept in the set register. From the set register, this result has to be written back to the memory. For that, memory address register will be loaded with the corresponding address to which the result has to be stored. Also, from the set register, the result will be transferred to the memory data register. So here we have the address, here we have the data. The address will be automatically available on the external address bus. From the memory data register, in order to keep the data to the external data bus, we use MDR out E signal, and accordingly a write control signal will be issued by the control unit, and we will wait for the data to be written to memory, waiting for MFC signal.